Tomorrow's quiz is pretty basic. Here are the main three things you need to know. First of all, you need to remember that an electric field points in the direction that a positive charge would move. So if this is my electric field, and I put a proton, or a positive charge, in it, the positive charge would move to the right. If I put a negative charge in it, the negative charge would move to the left. Electric fields point the direction a positive charge would move. The force on a charge from an electric field is calculated using the equation F equals QE, where Q is the charge and E is the strength of the electric field. A lot of people have been confusing F and E for some reason. If a question asks for electric field strength, that's the variable E, electric field strength. If the question asks for the force from the electric field, that's the F, force. I've seen a bunch of people in solving problems, it will give you electric field strength, and they've been using it like it's a force. It's not the case. Make sure you actually look at what the problem gives you. If it gives you force, that's F. If it gives you electric field strength, that's E. You could also use the units to tell. Force is in newtons, and electric field strength is in newtons per coulomb. Something that we covered with graphs about 2 weeks ago was that once a particle, let's say an electron, enters an electric field, it gets a force on it. That does not mean that its velocity automatically reverses direction. So if this electron had a velocity to the right and it enters an electric field, its velocity will decrease, and then eventually the thing will turn around and its velocity will be in the opposite direction. But the field causes a force which causes an acceleration, F equals mass times acceleration. And that acceleration, since this is an electron, would be opposite the direction of the field, meaning that the thing would slow down and then eventually turn around and go back out of the field. But something, if it enters a field with a velocity, it will keep going in the direction of the velocity until the field has turned it around. So keep that in mind. Just because something gets a force on it doesn't mean it automatically starts going in the direction of the force. It means it accelerates in that direction, and that could just be the thing slowing down. Finally, there is a question that's going to ask you to compare the strength of gravitational force and the strength of an electric force. Whoops. F equals QE. On objects, just remember that gravitational force on Earth is calculated with this equation, and force on a charge from an electric field is calculated with the equation on the right. If you remember that, all those things, you're good to go. See you tomorrow.